The purpose of this assignment is threefold. Actually, fourfold. To spark some interest when it comes to saving for your future, to use popular internet sites to research historical rates of return on popular investment vehicles, to demonstrate how to set up an investment schedule, and finally, to demonstrate how to utilize a powerful Excel function called equals FB, or the future value function. Investments play a significant role in your ability to accumulate and preserve wealth. No single investment is right for everyone. There are many different factors that come into play when choosing the right investment. I would strongly suggest you consider taking several classes to learn more about how to invest your money. The 3 classes that we offer at Cerritos College are Finance 125, called Personal Finance, Finance 51, called Retirement Planning, and Finance 126, which is called the Stock Market and Investing. There are several different types of common investment vehicles. Some of them are cash investments, bonds, and stocks. There are also others like commodities, real estate, foreign stocks, and etc. Each one of these types of investments can have several different investment vehicles incorporated within the above categories. Some are safer than others. In any case, the returns on all of them can be researched and then used to project future growth. So let's talk about getting started. First, we will set up an investment schedule using the principles of basic mathematics. We will use a fixed investment amount and a fixed interest rate to make sure our math works. Then we will build our schedule out in the longer term by using the equals FB or future value function. Finally, we will learn how to research actual rates of returns on real-life mutual funds. And then lastly, we'll insert these rates into our schedule. In your handout, you have an example of a typical investment schedule. I would keep that handy as we walk through the steps. I would suggest that you use the same values given in the handout so that you can verify your answer once you create the template. We will set up a table as shown on the example. We will enter our formula so that the answer section will recompute using any parameters that you enter. This means it should be 100% flexible and 100% cell-referenced. We will carry the schedule out to a minimum of 3 years or 36 months, and then we'll total up the amounts by year. Again, refer to the example often as we're working through the problem. So let's get started and open up a blank Excel template. On my template, you will see that I've documented my work appropriately by including my name, the file name, and a brief description of what my template will accomplish. I'm using the starting values that are used on your handout, which is a monthly contribution rate of $50 and a fund that returns an average of 12%. Later on, when we research the rates, I'll come back and put the actual fund name in here. But for right now, we're going to just create an investment schedule with the stated amount so we can check our accuracy. So, a compounded investment schedule takes many forms. Here's an example of just one. So just like we did on the amortization problem, I'm going to start out by listing my payments. I'll put in the first interval, and then I'll use the fill handle to show at least the first 36 months. And again, you don't have to be exact, so because I have more than 36, I'll get rid of the 1. And the fill handle also works well with dates. So I'll put in my first date of 1/1, let's say 2017. And then my second date will also be on the first of the month. And once I have those first dates in there, I can also use the fill handle to drop the various dates in. Okay, and again, you want to think very carefully about cell references. We want to make sure that our answer section is 100% cell referenced, so that if we make any changes in the data section whatsoever, it will recalculate on its own. So in this exercise, we're using contributions of an annuity, which means the same amount at the same time for a specific period of time. So in this case, my contribution margin is going to be the standard $50. So once again, I'm cell referencing that, and because it's not changing, I'm going to hit the F4 key to make sure that I use an absolute reference. That means when I copy the contribution dollar amount down, it will stay as cell E8 or $50. The next step is putting in my interest. Assuming we start out with a 0 starting balance, my interest is going to be the sum of what I started with plus what I just contributed, and I'm going to apply the interest rate to that sum. So let me put parentheses around my principal balance. Remember, the formula for interest, as we've been studying for a while, is principal times rate times time. There's my principal. Now I'm going to go grab my rate, and my rate is up here in the data section. So my rate for this case is 12%, and because the 12% is static, I'm going to again use the F4 key to turn that to an absolute cell reference, and then I'll multiply that by my time, which is 1/12, because I'm making monthly payments. So again, the formula is the principal times the rate times the time, and when I press enter, it will give me the result of 50 cents. And so my new cumulative balance will be what I started with plus the contribution plus the interest that I just earned. And I'll press enter. And again, just like on the amortization schedule, if you did this properly, you should be able to highlight the whole line and using the fill handle, copy it down to all the different payments, and you can check your answer against the handout that I gave you. In my case, with the parameters I've entered, it tells me that after 36 months of investing $50 a month with the interest rate of 12%, I would have accumulated $2,175.38. Check that against your handout to make sure it's accurate. As you will notice on the example, we also kept track of the year-to-date contributions and earnings and total. So just like on the amortization problem, I will use some color to highlight where the year point marks or the benchmarks are. Let me just put some color in there so you can see what we're doing. And we'll do it on the 12th month and the 24th month, since that would represent 1 and 2 years. And again, you have a model to look at. We did the same thing on the amortization schedule. To compute the amount of contributions made for the year, you would sum up the first 12 months of contributions, and we would do the same thing with the earnings. We would sum up the first year of earnings from the 1st to the 12th, and then we would also sum up the contributions and the earnings. And finally, we would develop our cumulative totals, which will be the sum from year to year. So we started with 0, and the first year we added on 640.47, and that'll give us our cumulative total. We'll do the same thing for the second year. In other words, we'll sum up the second year's worth of contributions, the second year's worth of earnings, the sum of those two items, and finally we'll keep track of a cumulative total. As you can see, the math here works. At the end of year 2, here's the amount I have. The end of year 2, here's the cumulative amount that I have. Now we're ready to try the future value function. So you could imagine that it would be a very tedious task to sit there and create a compound investment schedule for a longer term, let's say 10 or 20 years. So instead of doing that, we are showing you how to use the equals future value function. The equals future value function is described in a second handout that you have in your possession. This slide just shows a summary of that handout. There are 5 variables separated by commas. The 5 variables are shown here. The 5 variables in a specific order are the rate of return, the number of payments, the amount of the annuity, the beginning or starting balance, and the type of investment. The rate of return is the interest rate, which needs to be expressed in monthly terms if you're making monthly payments, as we're doing in our example. And the number of payments equals the number of periods in the interval of interest, or the time period that you're talking about. So if we're making monthly payments, then 1 year would be equivalent to 12 months, 2 years would be equivalent to 24 months, etc. Then we are going to enter the amount of the annuity, or equal payments, over the term of the investment, and we'll be entering that number as a negative value. And finally, the last or 5th variable is the type of investment. It would be a type 0 if made at the end of the month, or a type 1 if made at the beginning of the month. Okay, so let's give this equals future value function a shot. So just to recap what we've covered, we have computed or have the starts of an investment schedule. We need to take it out at least 36 months. In our demonstration, we took it out to the 12th month here, and we took it out to the 24th month here. Now let's go try the equals future value function and see if we can get exactly the same answer. So the last column of my template will say using, maybe I'll put value using the equals future value function. Okay, and again, you have a handout which describes in detail the 5 variables. And again, the key to this is making sure that the entire formula is cell referenced. So here we go, equals future value, and then again, 5 variables separated by commas. The first variable is the interest rate. So I'm going to go grab my interest rate here. And then I'm going to press the function key, the F4 key, to make sure that that's an absolute number. And the reason I want it to be an absolute reference is because that interest rate isn't changing. Because I'm making monthly payments, I need to express that in monthly terms. So I have my first variable down. Once again, The first variable is the rate of return. The second variable is the number of payments. Since I'm on the 12th payment, I'm going to come over here and cell reference this 12, because if I cell reference it, when I copy it down, then I'll be able to just do a copy command. So let's go back over. The third variable is the amount of the annuity. In this case, it's a standard $50, but again, the goal is to make my template flexible. So I don't want to enter the number 50. I want to cell reference the $50. And as your notes will tell you, the annuity amount needs to be entered with the minus sign in this function. So I'm going to put minus, and I'm going to go grab my $50. And since that's not changing, again, I'm going to F4 that. Okay, so now we have the three variables. Again, to recap, we have the interest rate, we have the number of payments, we have the amount of the annuity. The fourth variable is the starting balance, which in our case is 0, so I'm going to go grab that. And again, that starting balance isn't changing, so again, I'm going to F4 that so that it doesn't change. And the last variable is the type of annuity. 0 would be if the payments are made at the end of the month, and a type 1 would be if the payments are made at the beginning of the month. In our case, it's a type 1 since the date is the beginning of each month. And when I press enter, I will get exactly the same amount that I got when I did my longhand math schedule. That's a demonstration of how you use the equals future value function. It's a very, very powerful feature because you can calculate how much your investment would be worth at 5 years out, 10 years out, 20 years out, without having to do 20 years worth of calculations. I hope you see the importance of this in your personal financial lives. The other important thing is, once you've calculated the equals future value function, as we did up here using 100% cell references, we should be able to copy and paste this formula down our schedule. So I'm going to hit Control-C to copy and Control-V to paste. And you'll notice that again, the equals future value function that we used changed as it should have changed with all the cell references, and once again my second year is right on target. That should work all the way down your mathematical schedule. So let's take a look at our cleaned up schedule one more time before we research interest rates. So you can see that I've shown at least 3 years worth of activity, and I've also used the equals future value function to prove my math is correct. When you get down to the longer term benchmarks, make sure you follow the directions in your handout. They may be a little bit different from the hard copy that was presented to you. Here we're showing the long-term effects for 10, 20, 30, and 40 years, and you can see that by only putting $50 in a month at a rate of 12%, we have close to $600,000 if we're able to work 40 years. Now the question always comes up, are there investments that have 12% returns? And the answer is yes, but you need to search for them. So the last part of this example, we're going to go into a site called Morningstar.com, and we're going to search for such investments. Remember that retirement planning is about using projections to make our best educated guess. No one has a crystal ball. We don't know what's going to happen in the future, but the best way to predict the future is by basing it on past historical results. So for the last part of this problem, we're going to go in and look up actual real-life funds with the hopes that we will replace 2 cells on here. The rate of return, instead of being based on 12%, will be a historical average that we'll look up in a moment. And again, don't forget to document the fund that you're choosing. When you follow the directions will instruct you to copy the URL address from the internet so that if you find a really good fund that I don't know about, I can check it out for myself. This is also a learning opportunity for me as well. So there are many places you can go to research funds. One of my favorites is Morningstar.com. One word, Morningstar.com. You can go to your browser and look it up. And here's Morningstar.com. We're going to take a look at mutual funds. And I don't have time to explain all that a mutual fund is, but you can Google it on your own. So we want to go to the Funds tab, which is right here. And it may ask us to log in. We want to use something called the Fund Screener. It's a free screener that's built into the program that will allow us to find funds that may be of interest to you. And here it is. It's called the Basic Fund Screener. So I'm going to click on that. And it may ask me to log in. If it does, you can create an account on your own, or you can use my free account. If you choose to use my free account, the email address that my account is under is dschmidt@cerritos.edu. And the password is the number 1 Cerritos. The number 1 Cerritos. And it will bring you to this site, which allows you to screen different funds. The reason that I like this site is because as students, you may not have a lot of money to invest, and this screener is going to allow us to choose funds that have a relatively low startup cost, let's say $500. Now that means that you need $500 to start the fund, but you can give much less than that every month, let's say $20 to $50, whatever you think you can afford. So we need to pick some parameters on the fund group. We could use a specific type of fund, and again, I don't have time to explain all these differences between these, but I hope that this will pique your interest so that you will start considering your options and take an investing class. I'm going to choose the U.S. Equity Fund because many of you would be familiar with companies that make that up. Morningstar category. Again, all of these have a meaning to them. I'm going to choose one that's going to have companies that you would be familiar with. I'm going to choose either a mid-cap or a large cap. You choose whatever one you want. And then the only other one I would suggest you enter is that your minimum starting point is 500, or maybe you can even choose 1,000. Again, that doesn't mean you need to invest that every month. It just means that that's what's required to start up. And I'm a conservative investor. I don't like load funds. There's 2 schools of thought on that, but for me, I want a no load fund, and I'm only interested in those funds that are fairly highly ranked by Morningstar. So you can pick whatever parameters you want, and in a moment we're going to press show results. It will search the database finding those parameters, and yours may list them in alphabetical order. Mine appears to be listing them. I'm trying to figure out. It also looks like alphabetical order. If you would like another order, like maybe from highest to lowest year to date, you could click that and it would resort the funds for you. And apparently I have a slow internet connection today. But here's just the first page of the funds. In this case, it's ranked from the highest year-to-date return to the lowest year-to-date return. You could look at any of these funds that you're interested in. I am very familiar with the Columbia funds, so I think I'm going to take a look at that. But you could pick anything that you're interested in and click on it. And again, you'll have to be patient because I am working with a slow internet right now. And once it pulls it up, it'll give you a lot of information, much of which you may not understand because you're brand new to the concept. Again, my hope is that this will pique your interest. And once the site populates itself, we're going to be looking for historical rates of return. And the best place to find that is under the Performance tab. So I'm going to click there on Performance, and we will wait for the internet to tell us what the historical performance of the account is. This would tell you how much 10,000 would have grown into. I'm looking for total returns, and specifically I'm looking for the longest term rate I can find. This fund has been around at least 10 years, and with all the highs and all the lows, including the hit that we took in 2008, this fund has historically returned about 8.52%. So I would encourage you to take a look at the fund by using the Performance tab and find the longest term rate that you can find. That means with all the ups and all the downs, with all the highs and all the lows, this fund has on average over 10 years returned a rate of 8.52%. So I'm going to remember 8.52, and while I'm at it, I'm going to copy this URL address into my template because that's one of the requirements. So I'm going to go back to my Excel template. I'm going to replace the rate of return with the 8.52%. I definitely don't want that to round. I'm going to drop in my fund here. And also, you definitely want to give me the name of the fund in case I want to go research it. The name of this fund is going to be someplace at the top. Columbia Mid-Cap Index Fund. So you could either copy and paste that, or you could remember it and write it in. I'm going to take the lazy way out and paste it in here. And apparently, there it goes. Okay, once you do that, you're ready for the last step, which is you decide on what amounts you can afford. Maybe you do one for $20 and maybe you do one for $50. I want you to take some time and look at the results. You may not have $100 a month to put away now, but once you graduate from college and get your career going, that would definitely be something that you could find a way to set aside. Let's turn the $50 into $200, maybe looking further down the road. Investing $200 a month at the rate for the Columbia Mid-Cap Fund at 8.52% results in a total retirement fund savings of almost $1 million. So you need to think seriously about your retirement future. If Social Security is around in its present form, and I say a big if, it will not be enough to support your lifestyle in the way that you would like to be supported. You need to take the savings responsibility on yourself. And this is a great way to take a look at how much you can save if, and the key word is if, you start saving in your 20s right now. Not in your 50s, I'm 52. Not in your 50s, but when you're young, so that the compounding interest can work for you. As usual, I'm here to help, and I'm looking forward to reading your updates on Sunday night.